This conference will now be recorded.
Okay, so good morning, good evening, guys. Thanks for joining the session. So I'll go and share the screen and we'll get started. Okay, for the people who have not joined yesterday and who are new, and if you haven't looked into the yesterday's demo video, I'll just give a very 1 minute summary of the topics what we're going to cover, and request you to take a look into the yesterday's demo video for a detailed walkthrough of all these topics what we are going to cover in the in this batch. Okay, so very quick summary. We'll start with the Java basics, JVM basics, and followed by the assuming that we are going to work on a new application uh, which is going to get deployed. We will have the issue created in the code, which will have a response time problem, memory problem, a thread problem, and then we'll go and address those problems one by one. So we'll start with the response time analysis, and then we will get into the debugging those response time problem, followed by a week or so of memory related sessions with the basics of Java heap and stack, and then analyzing the memory problem, memory leak analysis for profiling, and then heap dump analysis, GC analysis, and then basics about the Java threads, thread contentions, thread dump analysis. And then we'll move on to the client-side analysis or client-side engineering, looking into various aspects of APIs that are available to validate and get the important metrics from the navigation API and paint APIs, client-side optimization, recommendations, all these things, everything with a real application. We will create problem in the code, and then we will deploy it, and then we'll identify the problem. And then we'll move into the monitoring aspect. We will learn the architecture and monitoring strategy, and then we will get in deep dive into the AppDynamics, both from the configuration perspective from a Java application, and also using the AppDynamics for monitoring, diagnostics, and then troubleshooting the problem. We'll also look into the open source monitoring using Telegraph and InfluxDB, and then we'll run some small tests to troubleshoot, to identify bottlenecks using these monitoring tool combination. And then we will move on to the Oracle database architecture. We'll try to learn the process architecture and then the memory architecture, important aspect of database monitoring from an application performance engineering perspective. Couple of important concepts about the parsing, and then the buffer cache, and then the common problem that will come with the database, Oracle database, and how to address it. And then we'll connect with the database to enable the snapshots, to configure the snapshot, to take the snapshots, and to get the AWR reports, and then analyze the same. So entire thing we'll cover it in the from a database perspective. And then we'll move into the non-functional requirements and engineering strategy. All the concepts, all the basics which we have learned, all the engineering activities which we have learned, we'll try to go and put a engineering strategy. And more from the future readiness perspective, we will look into the introduction to DevOps, and then the introduction to the cloud, which is very important because that is something very commonly asked question wherever you go, whether they use it or not. These things comes up everywhere. So on top of the core engineering, we'll also try to learn something that is required for the future readiness, one from the DevOps and second from the cloud. That is the very high level summary of what we are going to cover. But for the more detailed walkthrough, please look into the yesterday's demo video. Okay, so today we will go and start the session. Let me, before starting the session, I think there were a couple of people who called me yesterday and who messaged me, wanted to understand, is this really going to help them getting a new job or new project, getting into engineering area, whether we'll be able to answer the interview when it comes to engineering after going through the batches, right? Whether is it possible to clear the interview from an engineering perspective. There are two things, okay? One, as a pure performance engineer, if you're going to apply for any project or apply for a job, then it would need at least 3-4 months for you to practice these things to go and confidently clear it. That as a pure performance engineer. But if you're going to position yourself as a performance tester plus having an engineering knowledge, okay, having a fair bit of an engineering knowledge, engineering hands-on experience, if you can going to claim your mainstream is performance testing, but you also have knowledge on performance engineering, right? Then that will put you in a better shape when compared to people who only know performance testing. When compared to that, you can easily go and clear the interview, because interview is not going to be very hardcore into engineering. I'm saying just to after the batch is completed, once you do this hands-on by yourself, then you can position yourself as a performance tester with engineering knowledge. That will put you definitely ahead of the people who doesn't would know only performance testing, right? So, and then I've compiled a few common interview questions, right? And we'll quickly check how our sessions are going to handle or address those interview questions. One second. Okay. So I'll just go through a couple of interview questions. What we usually ask, or what it has been asked by the others, right? So that we will know whether we are addressing those or not. Okay, I'll just go through a couple of common things. What are the important JVM parameters? Difference between your stack and memory or heap memory. What happens if the thread stack reaches maximum limit? How to use different garbage collectors by passing VM parameters in Java? Can you tell the system to perform a GC? Have you ever witnessed a memory leak? How did you diagnose it? During a load test, how do you diagnose the memory issue? There are two things. One, during a load test, analyzing the memory is different, and then standalone as a early performance, addressing a memory leak is different. So how do you address it in two different ways? Are there any disadvantage of GC? What are the various issues that you have seen during the load test? How do you troubleshoot thread content issue? And this is very common, right? How do you troubleshoot a response time issue in general? Because most of the time developers will say they don't have a problem with the code or the deployment, and they will just keep on claiming that our scripts or test data is having a problem and it is giving a incorrect results. How are we going to address that? And how do you monitor and diagnose performance issue if there is no AppDynamics or Dynatrace? Even yesterday there was one person asking me about it. What would be your approach if there is no AppD or Dynatrace? Okay. Have you done any configuration in the APM tool? How basically the APM works? And how do you capture the memory stats in the Linux machine? How to enable the AWR reports? What are the various issues that you will observe in the AWR report? And definitely you will get a question on art parsing and impact to parsing, the buffer cache hit ratio, and the impact to the performance. Okay. And definitely in nowadays the questions around the client side performance issue, what kind of recommendation you give it, these things keeps coming in. What are the various cloud monitoring tool? How cloud monitoring differs from the other tool? Is performance testing really required for cloud or not? Because people say cloud will take care of scaling. So a lot of places, project manager, even in the real-time project, they ask whether do you really need this much of effort for performance testing, because cloud is going to guarantee you the performance. So is it really required or not? What is auto scaling? How do you validate it? Integration of Jmeter with Jenkins. Do you know to create pipelines and schedule your jobs in Jenkins? What is continuous monitoring? So all these are most of the frequent questions that you might end up, not for performance testing, but if you say you have a performance engineering knowledge, performance engineering, little bit of an experience along with the performance testing. Okay, and I'm sure at least 80% of the questions you would be able to answer it very easily. Um, for that, yeah, one is you should attend all the sessions, or at least even if you miss one or two sessions, at least have the recorded video and then get the session which you would have missed, plus have the entire things in your laptop. Whatever I showed you yesterday, have entire thing in your to learn, but unless in your own laptop, install these things, and then practice all the sessions whenever you get time, the weekend, or after the session is over, after the batch is over, within a month or two. Then I'm pretty much sure that you will get a lot of confidence in talking about the engineering, whatever you have learned. So two things: one, attend the session regularly, and then practice this in your own laptop or environment. These two things will help you to definitely get you the required confidence to either to directly start working on these kind of a project, or getting into an interview and then claiming yourself as a performance testing, plus you have an engineering knowledge and hands on into that. Okay, so that is something I wanted to share with you. Since there are at least 3 to 4 people who questioned that around this area, I wanted to just inform you everyone about it. Okay, so then give me 1 second. Okay, so I'm not sure whether my screen was freezed when I was talking about it. I was showing you these interview questions, which I was talking you over the last couple of minutes, right? I was talking about these interview questions only. Um, yeah, there was a message saying the screens are frozen. So just wanted to show you this is the interview questions what I was talking about, and then um, this is what I was talking about. Have this on practice environment. Um, yeah, please have these set up in your basic setup in your machine so that you can practice it. Okay, so yeah, before going to the starting the basics of performance engineering, right? For the people who have just joined today, I'll just show you the sample application which we are going to use it. I'll go to the, I have this um, Tomcat, in which we have this new application war file deployed, and then I'll go and start the application. So this war file, um, along with the this entire code, the Java application for the E library, right? This will be given to you in the Google Drive so that you can import it into your own machine, and then you can deploy it in your Tomcat, and then you can start using it. Okay, so this will get deployed. And the Tomcat is connected with the AppDynamics as well. Though anyway we'll learn that in the sessions how to configure all these things. But the Tomcat which is running in my machine, it is connected to the AppDynamics in the cloud, so that all the data will be pushed into AppDynamics. Okay, so this will get now started. I'll just go to the localhost. Admin 123, and MySQL is running in my machine as well as a service. I'll go and start it. So the e-library application stores the data for the all the librarian details, all the books detail, everything in the MySQL database. Okay, so the architecture is the one which we are going to use it for our course is going to be a Java application, which is connected to the to the MySQL server, and then there are also a few third-party calls that goes out from the Java application to another third-party server. Some HTTP calls will happen. As you saw yesterday in the AppDynamics dashboard, right? So you'll have a Java application connecting to a database and then connecting to a third-party server. Okay, so this is what the application is, and this is what we'll use it. Okay, and then the drive. Let me this drive is what we will give access to the people who gets registered. This will have the entire um, all the code for creating the memory leak, and then code for creating the response time problem, all the heap dump files, the XPOF files. Okay, similarly for thread thread lock issue related code, response time analysis code. So the one which you are seeing it here in the Eclipse, right? Say for example, if there is a admin login Java file, this will to start with, this will have a good code without any problem, and then we'll create some problem with a response time problem or a memory problem. So corresponding those Java files will be available in these folder, and then similarly for Oracle, a couple of AWS snapshots and query to enable take the AWS reports and few Java programs and the scripts, whatever we will be using it, the Jmeter scripts, a lot of scripts, GC related analysis files, your the Telegraph InfluxDB configuration files, all the one which we will be using it, right? Whatever I'm teaching you, you will be able to replicate that in your laptop. So the whatever required for that will be available in the drive, and in the sheet as well. All the information that is required for you to install the softwares that will be available here, so that you can just go to this particular URL, download the software and install the required Java or Eclipse or Tomcat, JProfiler, uh, everything you will be able to download it. And there will be a question and answer sheet in which you would be able to post your question, so that I'll be able to answer it offline whenever during a session or after the session. So these two, this drive and sheet, you'll get an access. Okay, so I just wanted to reiterate whatever we learn in the session, you would be able to practice it. For practicing it, all the softwares, all the required Java files, all the configuration files will be available in the drive from which you will be able to download. Okay. Okay. So let me go back here. Okay. So some basics of engineering stuff, right? Before we jump on to the core part. So assuming that most of us, right, would be doing these performance testing role, maybe 2 years, 3 years, 5 years, end-to-end performance testing, right from non-functional requirement, scripting, and then creating scenarios for load, stress, endurance, and then doing some basic analysis on the uh, your testing tool report, plus basic monitoring analysis, and then providing the complete report to your development team or project team. Right? That is our typical project activities that we do as a performance tester, right from the non-functional requirement till the reporting, and depending upon the experience and depending upon the role, you might do everything or you might just do few things, just a scripting or just the execution, and depending upon number of people in the project, depending upon your role, depending upon your experience, we might do end-to-end or few limited things. Okay, so when we think about what is next, right now with DevOps into everywhere, and then people talk lot of them talk about multiple skill set, T-shaped skill set, and you're working in a small DevOps team or pods team where everybody has to do everything, right? So what is next, right? So there are a couple of specific roles that are getting defined, right? One is going to be your SRE. Another one is going to be your full stack testing, right? The person who do the manual testing has to do automation testing, and also they have to do the performance testing, or vice versa. If a person who does the performance testing also has to do the automation testing. So that is more of a multi-skill uh, role. That is what the customers are expecting as a one kind of a role. Okay, so that is one aspect of what next. So you can probably, if you are a performance tester, you can upskill yourself to a functional testing area or a security testing area, so that you can be fit into that particular role of full stack testing. Second is more of an SRE role that is getting coined by some of the top giants like Netflix or your Google, Microsoft, where it is more of site reliability engineering. Usually they take care of these resiliency, operational acceptance testing, failover testing, and production monitoring, synthetic monitoring, real user monitoring. All these things they take care from the production perspective, making sure application is reliable, acceptable, it is running fine, kind of running some failover exercises, resiliency exercises. That is the role of SRE actually. But nowadays, again, they wanted to merge a lot of roles together, which means they're expecting a performance when they roll out the job description. They wanted to have this done by the performance testing team itself. So they will have one role saying you do performance testing, performance executions, and also do this resiliency or synthetic monitoring, production monitoring. So that is kind of one kind of a role. And third is not an additional role. It has been there always, which is going to be a core. That is the performance engineering, right? So as a performance tester, if you wanted to look for the next level of advancement, or to make yourself a job ready, right? So these are the three things. One, you can learn automation testing, learn functional testing or a security testing. Then you can be a full stack tester, growing yourself horizontally. Second is more from a SRE perspective, where you can go and learn all this synthetic monitoring, production monitoring, resiliency, right? So that you can also try to fit into a SRE kind of a role. Third is going to be your performance engineering, right? Which is always there, not a new role, but that is going to be your next step in terms of moving ahead with your career, being a performance engineer. And this is going to be always be there. These SREs and full stack testers, right? I think these things keep evolving and keep changing as well, because that is something introduced newly, and every organization has their own way of dealing with these kind of a role. And always it keeps changes, but one thing that never changes is going to be the performance engineering, as an advancement to your performance testing. Okay, so when I say performance engineering, right, this is going to be a combination of couple of things. So if you see it in the diagram, right, there are four things. One is testing, obviously. So you should have a good knowledge in performance testing for sure, which we think we already have it, right? Whoever is in the part of the call, I think pretty much they might have doing these scripting or execution, know what is a non-functional requirement, they know what is workload, they know what is concurrent user, they know all the basic problem that might come from a concurrency perspective, from a response time slowness, memory problem, CPU problem. At least then we know what are all things that can go wrong, from a testing perspective. So that is one knowledge that a performance engineer has to have it. And other three things, right? Other three things, there is a system analysis, programming, and then kind of a little bit of a networking administration. So these two things, programming and network administration, it is very good to have it. Right? We are not going to be a core network administrator or a application developer. But as I said yesterday, if you know programming, if you know any of the one of the programming knowledge, that is something very good to have. Even if you don't have the complete programming knowledge, at least basics of Java or basics of Python or basics of .NET, that is going to make a lot of difference when we go and handle this performance engineering, go and talk to the developer. Right? Just at least the ABCD of programming, because without that we'll always be in a shell thinking that that is something a big gray area which you don't know about it, so that we will not be able to go and do confidently all this engineering work. So at least to break that barrier, at least the ABC of programming is something you should know about it, and you should know that okay, this is what the developer is doing it. I mean, that's not a rocket science, right? And anybody can do it. Obviously, there are skill set involved, there is expertise involved, but a little bit of programming, a little bit of knowing what is what done by a developer, how do you create a program, how is that all these things happens behind the scene, how the deployment happens, how it is getting executed in a Tomcat. That's a basic level of programming. You should definitely, minimum level of knowledge, we should have it. And then in most of the cases nowadays, in even performance tester themselves, they spin up the environment, they deploy the server, they start the server, right? They install the tools. So for that, a little bit of administration, system administration and networking is really required to troubleshoot the latency problem between servers, between load generators and servers. You would need some of the network concepts to be understood, right? So programming, a little bit of programming, little bit of administration is obviously there is required for a good performance engineer. And then when it comes to system analysis, that is where entire things comes into picture, right? System could be your client browser, it could be a database, it could be your server, anything. Okay, so that when I say system analysis, it is the entire thing what I've listed here, right? From a system perspective, we should be able to review the system architecture. What are the components that is required in the that are there in your architecture? Before we go and do a scripting or testing, right? As a performance engineer, we should be able to review the system architecture and then at least understand or guess whether this architecture, this particular components, with that we will be able to achieve the SLA or not. For example, say if you have a login page and the business team has given you the SLA of login 3 seconds. Okay, so if you look into the components that are involved in the login, right, there will be a front end where you will go and type your login and password, and it will go through the your web server, and then it will go to your application server for your login validation. It will go to a database, and there could be a third party server, LDAP server, or there might be some other single sign on validation, right? So with single sign on validation, where you go to third party and then get the single sign on validated to LDAP server, or if there is going to be too many components involved in the login validation itself, right? Then you're pretty much sure that 3 seconds is going to be very difficult to achieve, right? So you can just go back to the architects or developers and review this SLA. See, there could be a functionality that is required for login, right? If SSO has to be there, SSO has to be there. If it has to be validated with an LDAP, it has to be done, because that is how the overall enterprise works, right? It's an enterprise level authentication mechanism. But for this particular application, if they say 3 seconds, it may not be achievable. So there has to be a trade-off between what a architect designed and what a business is expected. And you as a person sitting in the middle, who is a performance engineer, who has to make sure that SLA can be achieved or not, You cannot, you need to wait till you deploy the application, you do create a script, and then do a testing, and then go and say the login response time is 5 seconds or 6 seconds, right? So you can easily go and review the system architecture to a level where you can look into the components involved. You can look into the how the flow is going to go through, from which component to which component the control goes to do this login validation, and then you would be able to go back to your business team and say, see, this is what the enterprise level architecture, enterprise level authentication works. With this kind of authentication mechanism, you would not be able to achieve this 3 seconds. Increase the SLA to 5 seconds. Okay, so that is what we need to advocate to the respective team. Or maybe in the long term, if 3-second SLA is something very, very important for this kind of an application, you may have to probably ask the architect to come up with a different architecture, so that your SSO validation can be fast, or you might have some local authentication, whatever it is, right? That is something they will take a call. So those kind of an reviewing the components, reviewing the architecture is very important from a performance engineering perspective, and that is going to happen over the experience, not from day one or day two. But simple things we can definitely do it. Say as a performance tester, we script, we test, we find problem. But as a performance engineer, anticipate problem, right? Um, uh, Start looking into the architecture, start looking into the design document, right? Go and ask for the architecture, go and ask for the technical flow diagram, look into it. The first time, maybe we might not know anything, right? But we should keep asking questions. We should keep looking into the architecture diagrams, and then map it with the SLAs, so that you'd be able to better understand how the system works. That is the first step. Okay, and for that, all you need to do is just just confidently go and ask these documents, and then look into these, and then map with the SLA. I mean, that's it, right? Nobody else will do any magic. There is no tool is there. There is no other Dynatrace or AppDynamics is going to help you to tell you this architecture is going to meet the SLA or not. There's just we go and review it, and then have a discussion around it. Okay, and then we should be able to come up with a good engineering strategy, depending upon this architecture. Whether depending upon, is it a new application getting deployed, a greenfield implementation, or is it in a maintenance project or enhancement? Depending upon that, we might need to, because there are n number of things which we are going to do it in the engineering, right? Be it as a client-side profiling, or heap analysis, thread contentions, thread dump analysis, um, JVM benchmarking. So which one is required for what kind of application? Depending upon greenfield implementation or enhancement, we should be able to put together a good engineering strategy. And then, yeah, you should be good in setting up these monitoring tools, or making use of the monitoring tools, and all the profilings. You should have a good hands-on in all the profiling tool like JProfiler or JConsole, Visual VM, taking the thread dumps, analyzing the thread dumps, and experience in database analysis, experience in front-end client-side analysis. All these things is what it is required for a performance engineer from a system analysis perspective. So when I say in this diagram, system analysis will cover all these things: monitoring, profiling, dump analysis, your AppDynamics, database analysis, client-side engineering, rating engineering strategy, reviewing your architecture. Put together is going to be the system analysis component, which is what we are going to learn a lot in this session itself. Okay, so just to give you the high level view on what a performance engineering is, it's going to be a combination of all three aspects. And again, we don't need to be worried about whether I can do all these things. I mean, it is going to happen once you start doing it. At least few of things we already know: testing. You might already know a couple of administration, networking, right? And programming is something we will learn here. The ABCD of programming, minimum that is required for a performance engineer, and then the complete system analysis. And this is how it is going to spread across the entire SDLC cycle, right? From a requirement, design, development, test, and production. So from a requirement, if you want to map all these activity into these 5 stages, right? Requirement stage, and then one more thing, what I want to highlight here is, so where you look into here, right? All the activities are mapped against a different phase of SDLC, which means you as a performance engineer will be relevant for the entire SDLC cycle, if not 100%, at least 80% of the project duration, right? Say for performance testing in most of the project, right, we will get involved maybe if this is a 1-year project, right, from January to December, and we will get involved maximum by July, July or August, right? That is a maximum time in which we will get involved, right? But if you're going to be a performance engineer, right, where you're going to involved in the discussion with your business team more from a non-functional perspective, validating the non-functional requirements, and then comparing that with the design documents, and then working with the developer to do early performance, shift left performance, your memory analysis, code level profiling, method hotspot analysis, right? So all these things has to be done along with the development team, which means you will at least get involved instead of July. You will at least get involved from the February or March itself. So which means you will be relevant for the lot of activities, lot of entire duration. So which means your scope of work will get increased, your level of involvement will get increased, which means obviously your you'll be more relevant for the entire project SDLC cycle. So there are certain things you will do it during the requirement stage, certain things you will do it during the design stage, a lot of things you will do it during a development stage to fine tune your code to make sure every page doesn't have a response time problem or a memory problem, and with both respect to the server side and client side, benchmarking your JVM, fine tuning your JVM flags, and then during a testing as well, all these dump analysis, thread dump analysis, heap dump analysis, garbage collection analysis, and DB analysis, setting up your monitors, monitoring, all these things are going to be part of your testing, because usually during a test execution, right, what we do as a performance tester, we run the scenario, we monitor the test, stop the test, get the report, give the report. That is what we do it, right? But there are n number of activities that we can do it during a testing phase, right? Closely watching all the important metrics from the server side and client side, and if there are iCPU, if there are memory pattern is bad, if the response time is high, depending upon that, we go and take all these different dumps and analyzing your Oracle AWS reports, and then conducting the client side analysis parallelly to your load test execution. So lot of activities, that is something you will do it during the testing stage, which means if with lot of performance testing getting automated now, right, in DevOps, your execution is going to run automatically. Deployment will happen, your execution will start automatically. You don't need to go and start your test in LoadRunner or Jmeter. It will get started automatically, and there are a few things which will get automated from a reporting also. You don't need to go and compare the results, you don't need to go and pull the results. That is taken care by the DevOps environment itself, right? So that lot of your executions are getting automated, which means for us to stay relevant, I think we should be able to go and tell project managers that it is not just execution happening in DevOps. There are a lot of things which we have to do it along with the execution, like all these analysis, monitoring, thread dump analysis or heap dump analysis, early profiling, so that the project manager, when they go and approve the budget, they will know that we will be able to do a lot of things and we'll be able to add a lot of value add. Just doing an execution will not be able to justify, because things are getting automated. Again, from a production perspective also, once it goes to production, setting up the synthetic monitoring tool or real user monitoring tool, and then keep watching your these monitoring dashboard to understand whatever results we got from a load testing, right? We might have got the response time for all the pages during a load test, but in production, is it same response time what we are getting it? We might have tested for 1,000 user. Are we really getting 1,000 user in production? Is it less or more? How the workload increases in the daytime and decreases in the evening time? So we need to understand all these various patterns in the production. That is also going to be one of our engineering role, so that we can come back to the when we are going to do a next level of testing, we can include certain new functionalities that you see in production. We can remove a few functionalities which is not happening in production, increase the your either your number of servers or increasing your number of concurrent users, depending upon the actuals what you see in production. That is what we call it as a production feedback. Okay, so whatever you see it in the production, understand, observe your system, and go and correct your workload or correct your configuration in your testing environment. So that is very important for you to do that feedback from the production. So the when you see you single person who can do all these things during a development stage, testing stage, production stage, then your skill set is more than what a normal PT people will have it. You have a lot of things to do it, lot of scope to do it right throughout the SDLC cycle, which means you will be relevant for the project. Even the things are getting automated from a execution perspective, from a reporting perspective. All the commercial tools, they are now automating the execution, automating the result analysis. Whatever we do it in Excel sheet, like comparing the response time with the previous analysis and highlighting that with the red, amber, or green, all these things are getting automated now. So then what is that you're going to do will be the question that will come out. And for that, I think all these things are going to be very, very useful for us. Okay, so our next thing is we are going to start this session, the first topic in our list, right? The Java basics. Okay, so I'll give a quick overview on what we're going to see tomorrow. So we're going to look into first topic, think like a developer. We're going to learn Java basics and JVM. And I'll go directly to the slide pack of this particular topic so that I can easily explain you. So for every topic, I will have the slides through which I will be able to easily explain you, easily make it understandable. And then along with that, we will make use of the Eclipse and whatever the tools for the hands-on practical way of teaching. Okay, so we will go and understand why Java performance is still relevant, how it is going to be still relevant for next 5 years, 10 years, so that whatever we are going to learn, it is going to be absolutely that is something there in the market, relevant in the market. Okay, then we'll just go and understand why Java, why it is so much talked about in the past, in the current, even in the future. And then we'll get started with the JDK, JVM, JRE. Few of you might know it, few might have not know what is the difference between these three components. And we'll also go and set up this in our Java environment, setting up the Java environment for all this JDK, JRE also. We will start doing it, because as a developer, or even if you wanted to install the tools in your own machine, you should know these things. You should install Java. That is going to be a JDK or JVM or JRE, and we have to go and set up this Java environment in your machine, which will go and do it, validate whether it is working fine or not. And then we'll go and look into some of the Java programming basics. We'll learn Java more from a skeleton perspective. I'll tell what is that skeleton perspective. We'll go and learn these basics. Okay, again, if you go and look into any of this Java courses, right, they will start with all these what is class, what is object, what is the oops concept, all these things, which will, for us, as a performance tester, getting into this theoretical stuff, definitely I'll tell you tomorrow. I mean, what are the typical bottlenecks when we face whenever we want to do. I'm pretty much sure that a lot of you might have started learning Java courses, and we might have stopped it in the midway. I'll tell you why and what's the best way of learning it also. I'll tell you. So we'll start with the programming basics, and then we'll go and create some Java project in Eclipse. We'll go and create simple class files, simple methods. We'll go and create multiple class files, and then we'll call a method from other class files, and we'll go and create a DB connection with a class file. We'll try to see how to add external jars, how to import those jar files, and how to make an HTTP connection in a class file. All these things we'll go and learn one by one, which will give you confidence on, which will give you the hands-on on what is happening inside a Java project. How typically a Java programmer is going to do it, create this program, We're going to talk a lot about the problem is in this class, this method is calling that method. We're going to see that waterfall chart, and then we're going to say that there's a problem with the DB connection or a third-party connection. For all these things, we should know how exactly it is done by a programmer. That is what we're going to learn. And then we'll go and create jar files, we'll go and create war files, we'll go and deploy it. Okay, and then we'll see how to do these things in a Tomcat, how to run this jar file offline, how we import and export this jar file to other teams. That is also we'll learn, and then we'll go into this JVM Architecture everything. Okay, as we move along, I'll give you the introduction about all these things. But for tomorrow, this is what we are going to learn. Okay, so I'll just take a pass now. If there are any questions around the session topics, around the course, yeah, feel free to ask now or send it in the chat. Or similar to yesterday, if some of you have any questions, you can just call me or send a message in the WhatsApp. I can clarify your doubts. Guys, anybody have any questions, any clarification on the topics that we are going to cover? The duration is going to be pretty much same. We're going to start at the same time, and depending upon the logical conclusion for that particular topic, we'll go till 8:10, 8:15, 8:20, depending upon the questions also. That's going to be an average one to 1 hour 15 minutes, 1 hour 20 minutes, and Monday to Friday. And Saturday, mostly will not have it, but depending upon the everybody's convenience, we can also have it in the Saturday if required. And this will go for the 3 weeks or 3.5 weeks, close to 25 hours is what is planned. Fine, guys. If there are no questions, feel free to ask the question. If not in the call, if you have any questions, feel free to ask the question over the chat or in the. You can just ping me directly, and we can discuss it. And for enrollment, you can reach out to Kumar sir. If you have any questions on the payment or anything related to the such things, you can reach out to Kumar sir again. He will be able to clarify your doubts. Okay, fine, guys. Well, just stop the recording, and this recording as well will be available sometime in the afternoon. And thanks a lot for your time, and we'll meet tomorrow.
Thank you, Satish.